Good evening. Today we are going to discuss about Maxwell bridge. Some people or my students asked me the question about Maxwell bridge, that how can we prove or how can we get any resistance R1 if three resistance are known and one is unknown. So let's discuss about this topic. Firstly, we determine our figure. There is a figure in which R1 is unknown. R1 is unknown resistance, whatever we have to find, and a self-inductor L1 is known. And if we want to balance the bridge, if L1 is here, so we have to put a capacitance or capacitor C in the other arms, and the arm, if the arm AB, then we have to put the capacitor in the CD arms. So there is a R1 unknown resistance, R2 known resistance, R3 known resistance, and R4 known resistance. We have to find out R1 in the presence of self-inductor L1, capacitor C4. So how can we find out? You are saying that current AC is given to the circuit. So we already discussed in our 12th class that the balance condition of the bridge is similar to the Wheatstone bridge. Maxwell bridge is similar to the Wheatstone bridge, in which the balance condition is Z1 Z4 equal to Z2 Z3, or we can say it that Z2 upon Z1 equal to Z3 upon Z4. So determining the values by the figure Z1 Z4, it means Z1 is what? Z1 is R1, where the resistance R1 is applied. R1, it is unknown, but we have to put R1 plus L1. We can write it L1 by J omega L1. We studied L1, it is equal to Z omega L1 in 12th class. And Z4 is what? R4 and capacitor is in parallel condition. So we can write it as a R4 upon 1 plus J omega C4 and R4. It is equal to balance condition of Z2 and Z3. What is Z2? Z2 is R2 and Z3 is R3. So we can proceed. Open the bracket as R1 R4 J omega L1 R4 multiply, and J omega L1 as R4 we can multiply. So R1 R4 plus J omega L1 R4, it is equal to R2 R3. We can write it R4 upon 1 plus J omega C4 R4. So it is cross multiplied by R2 R3 and J omega C4 R4, R2 and R3. Let us separating the real parts and the imaginary part both separately. So we can write it as real part. What? Real part is the R1 and R4. We can write it here R1 and R4. And what is the real part in the other side? Is the R2 and R3. So we can write both real parts in a same way as R1 R4 equal to R2 R3. If we want to get R1, the unknown terms, so we can write it as R1 equal to R2 R3 divided by R4. So R1 can find R1, it is equal to R2 R3 upon R4. Same, in the same condition, by separating the imaginary part, we can find out the self-inductance as L1 from the equation 1. It is equation 1. How? The imaginary part in the previous equation is j omega L1 R4. It is equal to j omega L4, j omega C4 R4 R2 and R3. Imaginary part separating. So j omega L1 R4, j omega L1 R4 and j omega C4 R4 R2 R3 here. So the imaginary parts are separating and some values are cancelled out from each other. That j to j, omega to omega, R4 to R4 cancel out. So the left part is what? L1, which is self-inductance of the Maxwell bridge. L1 is equal to R2, R3 and C4. So self-inductance value in the Maxwell bridge it is equal to L1 equal to R2, R3, C4. So we can say that if R2, R3, R4 or any three resistance are given and one resistance is unknown, we can find out by the Maxwell bridge. We can also find out this R1 as Wheatstone bridge. So I can say that, we can say that Wheatstone bridge is probably similar, approximately similar to the Maxwell bridge, and we can find out the resistance in the presence of self-inductance or any inductance and capacitance. So the doubt is clear and we can discuss if you are not satisfied with this topic.